Thanks everyone for joining our session. It's really exciting to see you all here. We're gonna make a short presentation today about operating Neo4j in a Kubernetes cluster and what we as a team work and do to make things simpler for customers to run Neo4j in a Kubernetes environment. So Harshit and me, we both work on the same team. We are part of the quality team, but we are also part of a small sub-team which we call self-managed cloud solutions. So we're gonna kindly ask you to raise your hand if Kubernetes is part of your daily work. Okay. You have tried at least once to deploy Neo4j in a Kubernetes environment. 4 people. You think that's an easy and straightforward process. Okay, so we're gonna talk a bit about what we do to make things easier for this process to go through.
So to begin with introduction, so what is Kubernetes? A very, very simple question, and the answer is, I don't know. Don't look at me. So before we dive straight into Kubernetes and Helm, what we are going to do is we are going to do a quick recap, and Bledi here will help us with the quick recap.
Yep. Some of the most used container technologies nowadays, we have Docker, which helps us to create fully portable applications in secure, isolated, lightweight environments, whilst making better use of CPU and memory resources. We also have Kubernetes, which helps us to orchestrate large groups of containers and to run auto-scalable self-healing applications in often complex production environments, including hyperscale public cloud. And then we have Helm, which is a package manager and allows users to create complex Kubernetes environments and run applications like Neo4j without the need to create and maintain potentially hundreds of lines of YAML files. So this is basically how we can run a Neo4j container via Docker, which is quick and easy, but it's somewhat limited in orchestration and scaling. Then we have Kubernetes, which is powerful and customizable, but you have a lot of YAML files to maintain. And with Helm, most of this complexity is removed. You can just have a single values.yaml file and run a single Helm install command to bring everything up. So Neo4j Helm charts are in-house developed charts made public via our GitHub repo, which is neo4j/Helm charts. It allows you to install Neo4j cluster and standalone on Kubernetes cluster, along with many cool features. And we highly encourage you to go and check it out. There's also documentation showcasing how to use the Helm charts. And it's also kept up to date with the latest Neo4j releases. So over to Harshit.
So for the operations, right? So this is going to be the fun part of today's session. We are going to do a demo. We are going to start with installing a Neo4j cluster on a multi-AZ Kubernetes cluster. And in that installation, we'll be showing you how to install the APOC plugin. And we'll have some fun with Cypher basically loading some data. And in the end, there's a surprise small demo, which is Neo4j-F. I hope you guys can figure out what that is. So stay tuned for that. So I'll quickly move on to my terminal. And so what I've done is on the GKE, I have a Kubernetes cluster already up and running. It's a 6-node cluster that you can see. Let me just quickly do k-get node. So basically K is a kubectl client that Kubernetes provides. And just to prove you that this cluster is on a multi-zone, this is basically 3 instance groups of this particular Kubernetes cluster, and you can see that it's divided into 3 zones, US West 1A, 1B, and 1Z. And out of this 6 nodes, what we have done is we have basically labeled 3 of the nodes as alpha, beta, and gamma. And the Helm installation is going to install all our Neo4j pods on these 3 specific nodes. So just to showcase that, what I've done is I have this command sheet that I'll be referring to throughout this demo. And just to give you the list of nodes that we have named as alpha, beta, and gamma, I'm just going to fire some commands here. So out of the 3 nodes that we have, out of the 6 nodes that we have, these are the 3 nodes which are named as alpha, beta, and gamma. Alpha is West 1A, beta is West 1B, and gamma is West 1C. So you can see also that I have 2 more tabs here. So this one will be a watch command where we'll be showcasing all the pods and all the services which are getting created. So yep, let's begin. So what I'm going to do is, so basically we are going to get a cluster up and running. So we are getting a cluster of 3 core members, and we'll be also installing a load balancer so that we can access that cluster core member. So I'm just firing this install cluster core member here. And as you can see that the pod will come up shortly here. Container is getting created. Similarly, I'll go and quickly do a core 2 Helm install. And we can see that the pod core 2 will come up and we'll do a core 3 installation.
Using a load balancer for each keyboard or Bolt does discovery for the job.
Yeah.
So are you, but you're using a load balancer on both so that Bolt comes up. Right? Is that Bolt has a balance in the job?
Basically, to access the 7474 and the 7473 port, so we are using that. So, and now we are going to install the load balancer here quickly. And yes, the demo gods have started working with us. So yeah, the LB is up. I'll quickly do an installation of the standalone as well as why we are doing this is mainly for the surprise in the end. So yeah, meanwhile this is going on, this will take some time for the cluster to come up. I'll quickly show you. So if you have seen the Helm install command, we are basically providing a values.yaml file. So each core member has its own YAML file. So it's same for all the 3 cores. So we'll quickly go through the YAML files that we have. So you can see that initially it's the Neo4j resources that we are defining, CPU, memory, the password we are setting, the Neo4j edition that we want to use. We are using the enterprise edition here. And because we are using the enterprise edition, we have to accept the license agreement. And this is a very cool feature that our Helm charts provide is you can use a custom image. You don't need to use exactly the Neo4j image. So for the APOC plugin installation, we are using a custom image here, which is basically a 4.4.6 Neo4j base image with APOC plugin inside it. Now, in order to persist data, we are using GC persistent disk here. Now, all these disks, data core 1, for core 2 is data core 2, for core 3 it's going to be data core 3. These are all already created in the Kubernetes cluster, and this is how we are going to basically integrate our core with that GC persistent disk. Now, this is the feature, node selector feature, which allows you to assign or deploy your pod on that specific node, which is the node alpha, beta, and gamma, which is on a multi-zone Kubernetes cluster. And then this is a config section where whatever you define in the neo4j.conf file gets come here under the config section. And this is the new feature, which is not yet released. This is part of the 4.47 productized Helm charts release, apoc_config. So whatever that comes in apoc.conf comes here. So you can see that I've mentioned a very customized key value pair here, apoc.jdbc.bledi URL. So the moment our cluster comes up, we are going to access the browser and we are going to see that this apoc config gets loaded. So let's quickly take a look at this. It is still in the running state. Okay, core 2. Okay, guess what? I didn't fire the core 3. So I'll just quickly fire that core 3. And so the reason, so you can see here that we have core 1, core 2, and core 3. Core 1 and core 2 are in running state, and for core 3, it's in the pending state. And the moment it gets into a 1/1, that means that the cluster is formed. So that means that our cluster is in a ready state, and the moment that happens, we can begin our operations, basically accessing the browser and firing some APOC queries and seeing the APOC data. So basically, we have some causal cluster configs which are deployed in the Helm charts, which get enabled only when you are deploying a cluster. So basically, there's config called as dbms mode, which you set for standalone, it is a single, and for cluster, it is core. So when you do that for clustering, specific clustering configs get enabled, through which it basically do the listening addresses, how do you connect to it, and that's how the cluster gets formed.
Okay, well, I know, I understand how it, what's the bit today?
Sorry?
You said up there, when you get 1/1.
Yeah, yeah.
What is the trigger to make that 1?
It's the Kubernetes liveness probes.
The line is-
Yeah.
Okay, so they're checking those.
Yeah.
Yeah, yeah.
Save for that.
Correct.
Yeah.
That's
Yeah.
well.
Cool. So yeah, the demo guards are working because I missed triggering the core 3. So we'll just wait for a couple of more minutes and we'll get the code up and running. And yeah, so it's a stateful set. Yeah, yeah. So these are all the 3 cores that we have. As you can see, the configs are exactly the same. The only change is the disk name that we have and the node selector name, node name alpha, beta, and gamma. Now again, it's not necessary to have the same. You can have any kind of label that you want. So just to be very simple, we have kept it as alpha, beta, and gamma. So yeah, regarding the standalone, meanwhile that is coming up, we'll just show you the standalone.yaml file. It's a very simple YAML file that we're using. Same thing, Neo4j resources, password addition, accept license agreement. We are using the same custom image and we are using the same volumes here. With basically, it's not a persistent disk because we are using a default storage class with a very minimum storage of 2 gigabytes. So another thing that I'd like to share here is that because we have GC persistent disk, if you have like a AWS Elastic Block Store or if you have something for Azure, you can provide here as well. This is very much customizable to your needs for different cloud providers.
Change the EXP for it.
Okay, sure. So yeah, just 10 more seconds, I guess, and the browser should be up and running. Meanwhile, I'll just copy this. So yeah, this is the service list that we have, and this is the cluster IP that we have, LB-Neo4j. I'm just going to copy it and just create this. Hopefully this should get ready in any time soon. And yeah, similarly for standalone, because we are using an enterprise edition, we have the service list here on the 3rd tab, where this is the standalone cluster IP. So whenever you create a standalone Neo4j instance with an enterprise edition, you get the load balancer here. So you can use that IP here. So we're using the 7474 port here to get, so this is a standalone browser. Meanwhile, the cluster comes up. Okay, it's still in a pending state. So sorry. I have to do a quick insufficient memory. Okay. I know what the issue is. Yeah, K get pods, it's basically not assigned here. Alpha, beta, and gamma. You can see here core 1 is assigned to alpha, this is to beta, and yeah. Let me just quickly do core 3 uninstall and standalone, because the reason is standalone is assigned to the gamma node. That's why it was not getting installed. And I'll do a quick core 3 installation. And this will, the moment it moves from pending to container creating, yeah, it means it has got the node assigned. So a good example of how to troubleshoot your issues when you're presenting something like this. So yeah, it's in running state now, and a couple of minutes the core should get formed. And now, as you can see, we did another standalone here, and it came up the container creating. It means it is assigned to a node. which is not part of our node selector alpha, beta, and gamma section. So yeah. Any questions until now, if you have, for the values.yaml or anything that you want to ask in general?
Can you show me the selector again?
Yeah.
Got it.
So basically, this is a node name alpha, and this is where we label the nodes using the kubectl. So this was already done before when we got the GK cluster up and running.
Is the APOC config that you guys are going to release, is that like a config map that gets written into a file?
Yeah, yeah. It's basically a config map which is getting created when you provide this APOC_config, and all these configs are there. So it is getting created as part of a config map. Yeah.
Can you try to access the IDs?
Yeah. So service LB Neo4j. Because it's still in the running state, it will take a few minutes for this to get into ready state. Standalone should get ready now anytime soon. Yep. And the browser should load. Perfect. You can see that the cluster is getting formed now, 1/1. Similarly, the core 2 and core 3 will be in a ready state as well. And the moment that happens, the browser should come up. And yep. Cool. So we'll do a quick login. The password is the same, Neo4j and password. Just to prove the APOC config gets populated, we are going to fire this simple APOC query, which is basically seeing the customized URL is getting populated or not. So we are seeing the key apoc.jdbc.bledi.url, and it has a value as jdbc foo.bar. This is exactly the same value that we had set in our YAML files here, right? And now the playing fun with some cipher part, what I'm going to do is I'm going to create 3 databases here, db0, db1, and db2. I'll explain after firing the queries what these databases are and why we are creating 3 databases here. So meanwhile this creation is happening, I'll just quickly copy some cipher and do a quick refresh. So we should be good to fire the cipher query the moment we have the 3 databases populated here. So we have db0, db1, and just one more database to come up. And then, yeah, here we go. So we are going to fire this big query, which is going to work across all the 3 databases that we have, right? So we'll go through it. Meanwhile, that is getting processed. So we are basically loading, so db0, db1, and db2, right? We have 3 databases. db0 is the product database, where we are basically getting all, we are basically loading all the product data from this load CSV function that we have. We are loading all the products, all the various categories and the suppliers list into this product database. The db1 is basically your customer EU data, right? Which is basically all the customers which are in the EU countries, for data for all those customers, their orders and their respective products are getting loaded in the db1. And the db2 is about the customers which are in the AMR region, similar to db1, but it's just to differentiate between AMR and EU customers. So yeah, this is done, the query is executed. We'll just do a final match, simple basic query on the db2 to showcase some really beautiful graphs. Perfect, so it works fine. So this was basically installing your Neo4j cluster on a multi-zone AZ Kubernetes cluster, getting the APOC plugin in, showcasing the APOC config feature, and doing some Cypher. Now is the surprise part, and for that I'll ask Bledi to come over and help with that. Let me just quickly switch. Here you go.
Okay, so we're gonna showcase a relatively. Oh, sorry.
All the demo gods are here in this room. You know, they're all acting upon us. Perfect.
Yep, a relatively complex query that will use all these three databases that we created, and it will find all the customers who have bought discontinued products in the meat and poultry category. So I'm just gonna go ahead and I will grab the standalone IP. I'm gonna update it in the, we have this surprise.yaml config, and I'm gonna explain later why I did this. So I'm gonna do a Helm upgrade of the standalone instance with the new standalone IP, and while this is getting upgraded, I will show the config file regarding Neo4j Fabric, which is basically the same. The resources and CPU that we allocate, we specify password, enterprise edition with custom image, and the storage class that we use here is because we don't need persistent data for this. How Neo4j Fabric schema works is so with Neo4j Fabric we can execute queries in parallel across databases. We can chain queries for sophisticated real-time analysis, and we can query a database composed of other databases. This is a simple schema. Here is a schema without a single point of failure, but we will use just one Fabric instance to query the cluster. Here we specify a Fabric database name, a routing server, which is the standalone IP, and database URI and the names of the databases we want to query from the cluster. I'll check if this is up yet. Just we need to give it some more seconds to the standalone pod to come up. Do you mean routing? Just the IP. That's all.
Yeah, it's in the product URI. Yeah, we have mentioned the cluster core members.
Yep, it's up. So I'm gonna copy the query that we want to run here. We need to wait for the Fabric database to become available. And here we can see all the customers and where they are based. These are all the customers who have bought, as I said, discontinued products in the meat and poultry category. So this is just a short showcase of running Fabric queries on a Neo4j Kubernetes environment. I think we have come to the end of this presentation, and thank you all for joining.